is bone at the microscopic level. Okay, we were talking a little bit about what that might look like. This is actually part of the diaphysis of the bone. Remember, the diaphysis is the shaft of the bone that's long. So I've taken the knobs on either end off, and we built this in class today. What each one of these individual paper towels represents is how all of the bone cells are organized. Each line represents a bone cell. Bone cells are called osteocytes. Each osteocyte can't bump up against the bone. The paper towel itself is bone. It can't bump up against the bone because if it does, it'll damage the cell. So there's an empty space that surrounds each cell. That makes each cell look like an island, and each circle look like a little lake. These little structures that look like lakes are called lacuna, L-A-C-U-N-A-E. Plural, they're called lacunae in the plural. These all help to make sure that each individual cell has its own little space where it can live. But here's the problem with that. If they're completely landlocked, or maybe I should say bone-locked, how are they supposed to get their food? We need to have a way of traveling, for food to travel in, and for all the waste products of the cell to travel out. Because the blood vessels are here. The red represents the arteries that carries the good stuff from the heart and the lungs and the stomach to the individual cells. The blue represents the veins. That's what takes away the trash. Any other solid trash might also end up in these tubes called lymph vessels.
Okay.
But these lymph vessels all go through what the cardboard paper towel represents, called the Haversian canal. That was a vocabulary term we've already seen. These Haversian canals, okay, are the little holes that you see there, and those are the holes that the blood vessels run through. But the problem, these cells on the outside don't have direct access to that blood. So for this reason, we've got to make sure that there are small cracks. They've got to be really small cracks in the bone, because if they're really big, then we all have broken bones. So they have to have very small microscopic cracks, and that's what the lines between the lacunae represent. Those little lines kind of act like canals dug through land, except this isn't land, it's bone. So instead of calling them canals, each one is called a canaliculus. But the first 5 letters are the same as the 5 letters in the word canal. So it'll be a trigger to let us know why they're there. Okay? Each individual paper towel is circular, kind of like a cylinder. It's a 3-dimensional circle, but kind of a rectangle also. But it's still more circular and rounded. So we're going to see that each one of those individual groupings of osteocytes is called an osteon. Now, instead of there being one osteon from the center of the bone to the outside of the bone, it's actually dozens of them that you'll see. But they don't make paper towels that small. So we ended up just making it be one. But that represents a huge bunch of osteons that are this way. In the center of the bone, if you remember, we have an entirely different area. No bone cells here, but it's in the middle of the bone. This, you might remember, is called the medullary cavity. Medullary has the letters M, D, and L, just like the word middle. And this is the middle of the bone, sometimes called the medulla of the bone, or the middle of the bone. Inside that, we have a chemical that is called yellow marrow. And so that yellow marrow, remember, that's fat supplies. When somebody who's anorexic dies, we say they were skin and bones. Well, what happened to their muscle? It's supposed to be on top. Their body ate that already, very slowly over time. And then, once the muscle's gone, then they'll start going in and taking these fat reserves. This is how people can fast for a whole month religiously and still be able to stay alive without taking in more fuel. If I drove my car for a month without ever stopping at the gas station, it would be dead, and it wouldn't go anywhere. Okay? But our bodies are capable to go longer than machines are, because we can lay up and store our energy, even inside our bones. There's a double purpose. Not only do we have an extra supply of energy, but we also makes our bones a little bit lighter they're not solid all the way through. Since they're lighter, it makes it easier for us to pick up our legs to walk or to pick up our arms when we want to raise our hand. It doesn't take as much energy to do so because it's not solid bone through and through. Much like chocolate bunnies at Easter aren't solid chocolate all the way through. There's much air inside. And I know, I was disappointed too. but it makes the bunny that much lighter to pick up. So a little kid can pick it up out of the basket. If it were solid chocolate, it'd be stuck in the basket. So there's a couple of purposes that serves. Right? And so that's what we end up seeing is what the model that we built. And I'm sorry we're out, but I wanted to make sure that you understood some of this stuff. So hopefully you'll be able to look at this, be able to download the video and watch it. And if you have any questions about it, of course, we'll talk about it more in class, and I hope you're there with me.
Thank you, Mr. Deeren.
No problem.